So to add and subtract rational expressions, you're going to do exactly what you did for adding and subtracting fractions. So we're on page 385 in your workbook. And so the reminder, of course, what you're looking for previously when we were looking at fractions, kind of like in example number 1, we would probably just tell you find a common denominator. It doesn't have to be the lowest common denominator, but it has to be a common denominator. And that's the same thing for rational expressions. Ideally, because rational expressions are just that much more complicated, it would be ideal to find the lowest common denominator for those. And then, of course, it's finding the equivalent fractions, and then add or subtract the numerators and reduce to lowest terms if possible. So that means factoring if needed when we're talking about rational expressions. So for class example number 1, let's just skip right to C, because I know that this is just practice. So for C, if we're looking at it, if you were trying to figure out a common denominator, what do a lot of people end up doing is they just multiply 8 times 3 and then times 12. That would give a common denominator and that would work, but you're then dealing with big numbers and it just gets that much more complicated. So what is a common factor? In fact, our common denominator, in fact the lowest common denominator, is going to be 24. So because we're looking at 24, we're multiplying this one by top and bottom by 3, this one top and bottom of course by 8, and this one top and bottom by 2. And so we've got then 21 24ths minus 16 24ths plus 10 24ths, and 21 minus 16 is 5, plus 10 is 15 24ths, and then we can see we still have a common factor of 3, so we can divide numerator and denominator both by 3, and we end up with our final answer of 5/8. Okay, another way what you'll probably see me start doing when we get into the rational expressions is we might actually take this and instead write it like this. Common denominator is going to be 24. In order to get 24, I'm going to multiply 7 times the 3, and then I'm going to subtract the 2 times the 8, and I'm going to add the 5 times the 2. So it's essentially the same thing, but when we get into some larger rational expressions, I might choose not to write the denominator over and over and over again. As well, it also helps me to see if I need to distribute the negative, because when we see if I've got a subtraction, like right down here, subtracting a binomial, that's going to get things really complicated, and that's where mistakes happen. So 21 minus 16 plus 10 all over 24, and of course that gives me the same answer. Okay, so moving on then for single variable rational expressions. Then again, do not forget that you also need to state your restrictions as well where required. And so restrictions only apply when we've got variables in the denominator, because we do not want the denominator to equal 0, because we can't divide by 0. So for A, we're looking at a common denominator of 4, 5, and 10. Our least common multiple is 20. So then for the first one, I need to multiply 3x times 5, and then 5 times 3x perhaps. That'll make a little bit more sense. And then the 5 will multiply by 4, so that's plus 4x, and then we need to multiply the 7x by 2. So with that, we end up with 15x plus 4x minus 14x over 20, and so that is 19x minus 14x, which is 15x over, or sorry, 5x over 20. It didn't leave us very much room here. So 5x over 20, and 5 over 20 of course reduces to 1 over 4, and so then that is just x over 4. And there's no restrictions because there's never a variable in the denominator. switching colors so it's not too confusing. So in this particular case, common denominator of 6, and so we're going to multiply top and bottom here by 2. So 2 times 3a minus 1, and I don't need to multiply this one by anything, by 1. And so it's just 4a plus 5, and this is all over 6. So we've got 6a minus 2 plus 4a plus 5. And that's all over 6, combining our like terms, then 10a plus 3 all over 6. And now we're looking at this binomial. Is there a common factor? Can I factor it? No, and therefore that is my final answer, and no restrictions, no variable in the denominator. So last one, common denominator of 24. So then we'll look at having common denominator of 24. So the first rational expression, our first fraction, would be 3 times 8y minus 3, and then minus 8 times 2y plus 1. So then distribute 24y minus 9, and distributing the negative 8, so minus 16y minus 8, and that's all over 24. And combining our like terms, then we've got 8y minus 17 all over 24. Cannot be simplified further, no variables in the denominator. Now what I'd like to just point out is if I had done this with keeping those expressions separated, and you'll see how complicated this can get. So top and bottom we're going to multiply by 3, so we'll have 3 times 8y minus 3 over 3 times 8 minus, and top and bottom by 8, so 8 times 2y plus 1 over 8 times 3. So then we're dealing with 24y minus 9 over 24 minus 16y plus 8 over 24. And so the biggest issue that people have here is that when you're subtracting, remember you're subtracting this whole thing. So you're subtracting not only the 16y, but you're subtracting positive 8. And that's where a lot of people make their mistakes, which is why I prefer to ask students to do it this way, so that they can see that that negative 8 is going to distribute everything. And right here, when they're combining their terms, they can see the minus 9 and the minus 8, making it minus 17. So obviously this is still correct if you are able to get to 8y minus 17 over 24. No problem, and that's great, but people are much more prone to making errors by doing it that way. Okay, let's go on to page 386 and take a look at those examples. So in this particular case, I'll just do example A. And so remembering with that 3x, the denominator is 1. So our common denominator is 8. So taking a look right here, black, so we have then top and bottom, because our common denominator is going to be 8 here, top and bottom by 4, so 4 times 7x plus 3, and plus top and bottom by 8, so 8 times 3x, and then minus, and I'm subtracting that whole thing. So even though I'm not multiplying it by another coefficient in order to make that common denominator, because 8 is already the denominator, I do have to distribute that negative 1 in. So then we're looking at 28x plus 12 plus 24x minus x plus 3 all over 8. And so cleaning that up, 28x, 24x is 52x minus 1x is 51x, and plus 15, and that is all over 8. There is a common factor of 3 in the numerator that I could take out, but it doesn't simplify with the 8, and so it doesn't matter. I can just leave it as is. If you'd like, you can factor that 3 out and leave it as 17x plus 5 all over 8. Again, no restrictions because there are no variables in the denominator. Okay, so let's move on to class example number 4. Okay, so having polynomials in the denominator, but they've given them all to you as common, so it's just keep the denominator and combine those numerators. So hit pause and you can go through and complete those. I'll also complete class example number 3 so that you can have a look at it. So I'll pause over that and you can take a look, and but I won't comment on that any further. Okay. Okay, so there's the solution for example number 3, part B. So if you want to hit pause and take a look at it and compare, you may. Otherwise, you can scroll down, and take a look at class example number 4. So I've combined those numerators. 2 plus 7 minus 1 is 8, and that's over x, and the denominator cannot equal 0, so x cannot equal 0. In this particular case, combining, I've got 6a minus 3 over 2a. I can think ahead and say, oh, there's a common factor of 3, but that's not actually going to help me at all. And so I could leave it as 6a minus 3 over 2a, perfectly acceptable, provided that you state the non-permissible value and a cannot equal 0, or you can leave it factored as well. For part C, once we subtract those numerators, we realize that numerator and denominator are the same, so of course that just equals 1, and the restriction, of course, being 3y minus 1 cannot equal 0, therefore y cannot equal 1/3. For the second one, you can see that, or the last one, part D, I've taken the time right here to show and remind us that we're subtracting this whole thing, so subtracting 2x plus 4, so 4x minus 2x is 2x, 10 minus 4 is 6, and then this time when I factor out a 2, I'm left with x plus 3. So the x plus 3's can factor out, so we're left with the simplified version being 2, and our restriction is x cannot equal -3. Okay. So let's take a look at class example number 5. And so right now they've got different denominators. And so when we take a look at part A, we've got 3 times p and 7 times p. And so p is already in common, and so we don't need p squared. So if you think about what is the smallest thing that I can multiply by each to make the smallest possible denominator, so our smallest possible denominator is simply 21p. So the first term that I'm adding, I can multiply top and bottom, so 5 by 7, and here top and bottom I can just multiply by 3. So then we're looking at 35 plus 6, which is 41 over 21p. That does not simplify, but I need a common, I need my restriction, which is of course p cannot equal 0. Oops. So looking at the next one, smallest denominator we could have would be 15y. So what do we need to multiply 3y by is of course 5 to get 15y. So then that's 1 times 5, which is just 5. And then the 6 needs to be multiplied by 3y. So we just have then 18y plus 5 all over 15y, and with the restriction y cannot equal 0. For the second one, common denominator, why do I keep saying second one? Third one, part C, we're looking at a common denominator of 6x, and so first numerator stays the same, 2x minus 5, and then I'm subtracting, and I need to multiply top and bottom by 2, so I'm going to distribute in a -2, into the 3x minus 2. So then we've got 2x minus 5 minus 6x plus 4 all over 6x, and that gives us negative 4x minus 1 all over 6x, provided that x does not equal 0. For part D, then, our common denominator is, we've got 2 times and 5. They share no common factors, so we're going to have 10, and then this is a squared, which is a times a, and so if I just multiply a by a, we'll get a squared, so 10a squared will be my least common denominator. So for my first term, I need to multiply top and bottom by 5, so 5 times a plus 7, and in this case, I need to multiply by 2a, so then it'll be minus 2a times 3. So then we have 5a plus 35 minus 6a over 10a squared, or negative a plus 35, or 35 minus a, either way, over 10a squared, and restriction a cannot equal 0. Right? Let's move on. So if we have different monomial or binomial denominators, again, it's just recognizing that these are binomials, so that's the whole factor. You cannot separate any of those. So this is where I look at this and think they've not left us very much room whatsoever. So for A, squeezing this right over here, my common denominator then is, because factor 2, factor x minus 4, nothing in common, so the whole thing then, 2x times x minus 4, is my common denominator. So let's go through that for each of them, and then I'll let you finish those up. So for B then, my common denominator, so 2y plus 5, y minus 3, those are totally different, and so that is my common denominator. I have to multiply both of those factors together. Same thing for C. Totally different denominators, x minus 5, x plus 1, no common factors, so then my common denominator will be x minus 5 times x plus 1. So hit pause, and let's come back to this then in a moment. Okay, so let's take a look at A. So how did I end up with this numerator? So if my common denominator is 2x times x minus 4, so I needed to multiply both the top and the bottom here by x minus 4 and x minus 4. And so that's why it's x minus 9 times x minus 4. On the second term, then, we've got 3x over x minus 4, which means I needed to multiply top and bottom by 2x then. And so that's why we have 3x times 2x. So multiply that out, that's expanding, so x squared minus 13x plus 36, and plus 6x squared. Combine your like terms. Next thing you're going to do is try to factor this, but don't go nuts, because what are you trying to check really is there a common factor of x? Definitely not. Common factor of 2? Definitely not. Well, can it be factored with x plus 4? Well, if it was factored with x plus 4, actually then the other one would have to be plus 9, since this is positive, and it can't be positive 9 because this is negative 13. So if I write that out just so that you can see that, so if I have x plus 4 is 1, the other one would have to be 7x to get the 7x squared, and then this is 9 because we want 36, but because it's positive 36, this would have to be 7x plus 9. But that's not going to give us our negative 13x, which means that it may be factorable. Perhaps, I don't think it is, but it's certainly not factorable with the x plus 4, so I'm not going to worry about that then. And I'm just going to write out my restrictions, which are x cannot equal 0, that factor of 0 would cause the whole denominator to be 0, and x cannot equal negative 4. and that's from that binomial. So let's take a look here. So again, if I have a common denominator, 2y plus 5, y minus 3, I'm multiplying y minus 3 by top and the bottom here, and 2y plus 5, top and bottom here. So that means then my numerator is going to be 4 times y minus 3 minus 1 times 2y plus 5. So we'll distribute that. So 4y minus 12 minus 2y minus 5 over, and yes, it's a bit of a pain, but we have to write this out every single time. Do not expand the denominator because you want to leave it in its factored form. It allows you to see your restrictions. It also allows you to see if you can factor anything, cancel anything with the numerator once it's been simplified. So 4y minus 2y is 2y, minus 12 minus 5 is, of course, minus 17. So that's not going to factor at all with either of the terms, binomial factors in the denominator, and so that is my simplified answer, provided that my restrictions being negative 5 halves and positive 4. Let's look at this last one. Oops. And so common denominator is x minus 5, x plus 1. So here we're multiplying by x plus 1 over x plus 1. And on the second one, we're multiplying by x minus 5 over x minus 5. So that means that my numerator will be big. It's 2x plus 1 times x plus 1 minus x minus 4 times x minus 5. So because you're subtracting, remember here, you want to find out what that trinomial is first and then distribute that negative in. So again, common error that people make. So here we go, 2x squared, and then we've got 2x and 1x, so plus 3x and plus 1. And then we're subtracting x squared minus 9x plus 20. Okay, so you're subtracting that whole trinomial, that whole product. So you've got x minus 5 times x plus 1, and so then that is 2x squared plus 3x plus 1 minus x squared, now plus 9x, because I'm distributing that negative in, minus 20, all over x minus 5 times x plus 1. And cleaning it up then, 2x squared minus x squared is x squared, 3x plus 9x is 12x, and 1 minus 20 is negative 19, which means that they've left us with something that is not factorable, and so we can just leave it as such. We do not have to expand that denominator, but we do need to state our restrictions that x cannot equal negative 1 or 5. Okay, so give that last one a try. It's going to be big because you can see there are no common factors with those three denominators. And so give it a moment or hit pause and I'll fill everything in and you can come back to it and see the solution. Okay, so our common denominator is a big one. It is x times x plus 2 times x plus 1, so that's a situation no different than if you had with numbers and you had, I don't know, 1/2 plus 1/3 plus 1/5. So there's no common factors, so your common denominator ends up being the product of all three. So we need to multiply this x plus 2 by both x and by x plus 1, and so that's why in the numerator I have 3x times x plus 1, and then minus, in this case, we need to multiply by not only x, but also x plus 2. And the last one, we're multiplying top and bottom by x plus 1. and by x plus 2. And so I've shown that on that second line here. So expanding everything out and then combining all of our like terms, and we have a common factor of 2. That's not actually going to help us simplify anything, but it does help us to see the remaining trinomial, to see that it can't be factored any further, to be able to factor out a common factor with the denominator. So just leaving our restrictions, so x cannot equal -2, -1, and 0. Again, I don't really care what order you do, but preferably you're either in ascending order or descending order for your restrictions. Okay, great. Time to do some practice.